You can imagine if you are in a really deep cave that it's pitch dark. So a little light will be so obvious, so unique, and it can guide you toward the access and it can save you. Bioluminescence is a phenomenon in nature that some of the organisms can glow. There was an idea if you can transfer this kind of light glowing phenomenon into human body, and it can be potentially used for scientific discovery in human biology. Protein folding has been a long mystery in the scientific field. In David Baker's lab, I have an idea to create this light emitting system from scratch, where we create new proteins not related to what you can find in nature. We're designing proteins that can shine light. The method that we use is called de novo protein design from computational programs based on the fundamental biophysical principle of protein foldings. One of the big advantages of this technology is what we call a non-invasive imaging. Traditionally, in order to measure the size of the tumors in a mouse, you have to first sacrifice the mouse and then extract the tumor out. But with the technology that we developed, you can image the mouse, put it back to the cage, and then image the next day. So you can provide a more long-term information of how those different cells grow in one single mouse. Currently, we are able to design multiple different colors, and with the probe that we're developing, we will be able to what we call the multiplexing, to see multiple events simultaneously or sequentially. I believe this kind of probe will have a broader application than biotechnology and biomedical developments. It can be useful for preclinical evaluation of drug efficacy, bioimaging at cell levels, or track tumor growth. The possibility to apply these technologies is limited only by human imagination. Being a scientist is not an easy job. You have to be resilient and you have to have the grit to keep it going. When we designed this, we have very, very little knowledge about how to make it work. So we have to create every single component from scratch. We have to make a lot of hypotheses, a lot of trials. So for this LOXES, the first de novo design light-emitting enzymes, we actually have to test thousands of different designs, and then most of them, they failed. And I still remember the moments where I saw that it actually glow in my hands. I was just so excited that we really make it happen. I really appreciate the interdisciplinary cultures that UCSC brought in. A lot of really supportive infrastructures, and we also have a lot of opportunities to get together to discuss the science. I think the whole community is a very dynamic environment for collaboration to happen. The ability to create new proteins, it's kind of like bringing us from a stone age to industrial revolutions. Eventually, we believe that our platforms, our probes, will bring light to many discoveries in the scientific field.